Hello, my name is Kylie Bain, and this is my Lab 2 report for Charged Tapes Part 2. So for the contents of this video, we'll start with an introduction, go through some key concepts, and then recap Lab 1, the assumptions, observations, and calculations of Lab 1, and then do the same thing basically for Lab 2. I'll show you the glow script code, and then we'll go through the what-if questions from the lab instructions. So the purpose of this lab was to create a model of two charged tapes, just like we did in Lab 1, and model the force of gravity and forces of tapes on each other. But this time we're going to model it as a line charge instead of a point charge. And then to do that, we'll apply the electric force, electric field equations, and Newton's laws equations to determine the interactions between the tapes. So the key concepts we use are the electric field equation, the force of gravity equation shown there, and Newton's second law, which states that the electric force in this case plus the gravitational force will equal 0. Then we'll also use Coulomb's law, which tells us that like charges repel and opposite charges attract. The electric force is directly proportional to the charge and inversely proportional to the distance. The two charges acting on our tape in this lab are the electric force and the gravitational force, so that the sum of those forces will be F net, which is equal to 0. And we also know that neutral matter is attracted to charged objects because of polarization. So to recap Lab 1, these are all my calculations and all of the numbers that we need to answer from the Lab 2 instructions. We assume that each U-tape is a point charge and each U-tape has the same net charge as the other one. And we're also going to ignore air resistance. And then observations from Lab 1 were that the tapes repelled each other, telling us they were the same charge, and because they were attracted to a negatively charged pen, that we can find out that the U-tapes were both positively charged. So Lab 2 assumptions, each U-tape has the same net charge, just like in Lab 1. We're going to treat it as a line charge this time, though, instead of a point charge, with uniformly distributed charge along both tapes. Divide each tape into 35 chunks, which would be modeled by the glow script code. We're going to ignore air resistance again and ignore the interactions between the charges on the same piece of tape. So here's the beginning of some things that I changed in the glow script code. Most of these are just values from Lab 1, and then lines 34 through 40 are making a function to return the electric field value. This is the rest of the glow script code. The first big chunk of code is modeling the arrows and chunks of each charge on the tapes and how they're repelling or attracting each other. Then the bottom is telling the computer what arrows to make and how big and what values and stuff. So this is the glow script model that I got out of that. It also showed that the electric force and the gravitational force were the same, but I did not include that in the screenshot. And then the what-ifs for this lab are, if we model the tape as a point charge like we did in Lab 1, the difference in the calculated charge on the tapes is 2.7 times difference. So the point charge clearly underestimates the actual amount of force, or the actual amount of charge, that's supposed to say of charge, on each piece of tape. And then the line charge model is much closer to reality. That is it. Thank you.